In this episode of the How to Do Your 20s podcast, I'm really excited. I have Dominic D'Agostino on the line, and we're going to be talking about the ketogenic diet. He is a researcher. He's got a vast wealth of knowledge, so I'm not going to delay any longer. Dom, first off, thank you so much for coming on the show. I really appreciate it.
Thanks, Travis. I appreciate being on.
So tell us a little bit about your story. How did you get involved in this research?
If I go all the way back, I think, I was always interested in nutrition. So that underlying interest kind of directed me back to what I am doing now, which I think is kind of nutritional neuroscience and even approaching it from the perspective of developing cancer treatments and other areas of research, nutrition-based, or what we call, nutrition and metabolism, because they're really impacting metabolism. That was in undergrad. So, probably even stepping in a little bit back in high school, I kind of had an affinity for nutrition in that, I was reading at the time everything from like Muscle and Fitness to Men's Health, and everything nutrition in those articles I would kind of read and digest. And as I got a little more educated through high school, I would actually go to the dig up the references that were referenced in many of the articles and go to the medical library and actually start reading the medical journals to figure out, to get a better understanding of the fundamental science of nutrition and metabolism. And then in undergrad, I studied nutrition science and biology. And then that later led to, I was always interested in the brain. And I did my PhD doctoral research studying physiology and neuroscience, and more specifically, the brainstem mechanisms or the neural control of our autonomic regulation, which could be heart rate and respiration and autonomic processes. I was always interested in, how the brain controls these processes, and we don't have to think about it. And all the neural circuitry and the physiology involved in that, including digestion and appetite regulation. And throughout my PhD dissertation research, I became very interested in scuba diving and really took a lot of classes in advanced diving. And kind of, that led to a postdoctoral fellowship that was really focused on working with the Office of Navy Research, which is part of the Department of Defense, and working with them to understand the physiology of extreme environments. And I went into it kind of more focused on pharmacology, but realized that a nutritional intervention would actually be more efficacious for what I was targeting than a drug therapy, which is grand mal seizures that are a result of oxygen toxicity, which manifests itself when breathing high levels of oxygen with a closed-circuit rebreather. It's a special type of device or specialized equipment used by our Special Operations Forces, including Navy SEALs. And I did some fundamental work to gain some insight into the actual problem, and then further research to develop a mitigation strategy to enhance performance and safety for those guys that are kind of in that high-pressure oxygen environment. So and did a lot of the fundamental kind of science, the neuroscience and animal studies, and we're moving them to human clinical trials. But so that's in a nutshell, I guess. And now I'm a professor, just got tenure recently, associate professor at the University of South Florida, College of Medicine, Department of Molecular Pharmacology and Physiology. And I'd like to squeeze in there nutrition and metabolism, because I was really kind of focused on pharmacology, but really need to emphasize that nutritional or metabolic interventions are very powerful approaches to not only something very specific like oxygen toxicity, but we have projects ranging in about a dozen different directions. So that's kind of what I do in a nutshell.
What are some of the projects that you currently have going on?
So I would say about half of the lab right now is students in are primarily vested into our cancer biology program or projects related to that. And that would be developing and testing nutritional interventions, which could be the ketogenic diet, calorie restriction, a lot of focus on developing and testing various forms of ketone supplementation. And that could be ketone salt or mineral salt preparations, various ketogenic fats like MCTs, and also ketone esters and different forms of ketone esters that are originally were developed for anti-seizure effects, because the ketogenic diet is actually the standard of care for drug-refractory epilepsy and many different types of seizures. And the development of ketone esters was sort of a way to circumvent the dietary restriction that's typically associated with getting into that therapeutic range of ketones to achieve anti-seizure effects. So if we can do it with specialized compounds with ketones, that's what we're doing, and we're testing that. So the projects range from looking at metastatic cancer, brain cancer. We have projects on wound healing. We have projects on glucose transporter type 1 deficiency syndrome, so rare metabolic disorders that are responsive to nutritional interventions like the ketogenic diet. Angelman syndrome is something that we study. It's a rare genetic disease with a very known persistent molecular pathology. There's no treatment for this disorder, but it's highly responsive to a nutritional intervention, which is a ketogenic diet, even more so than drug therapy. So the Angelman Syndrome Foundation is actually interested in kind of directing funding towards looking at that as a therapy, synthetic ketones in the ketogenic diet. What else? Wound healing performance. So it's looking at exercise performance, cognitive performance, and cognitive performance, or I should say resilience in extreme environments. So our warfighters need to go to, and even astronauts need to go to extreme environments of variations of barometric pressure and oxygen. So in a hyperbaric environment would be like the undersea environment where you're diving. And in a hypobaric environment would be at altitude, like the space station or on top of a mountain. And we want to ensure that people and military personnel in particular can maintain their performance and cognitive resilience in that environment. So we are interested in testing some of the metabolic strategies that we developed for particular pathologies or maladies, and then testing that in animal studies first, and then also in combination we can do human studies to look at that. And we do some just basic physiology work, like looking at the glycemic response to particular diets or supplements, and looking at blood glucose in particular, being able to develop nutritional or supplements that can lower blood glucose. One of my students is doing cancer research, but really focusing on muscle sparing nutritional interventions, whether that be branched chain amino acids or ketogenic diet supplements. So his actual specific focus is something we call cancer cachexia, which is a particular type of muscle wasting that's associated with cancer when it becomes metastatic, and the body kind of transitions into the state where it's hypermetabolic, and we have a variety of factors are elevated in the blood, like TNF-alpha, tumor necrosis factor alpha, that causes muscle wasting. And then that's a big reason why people with cancer succumb to the disease, is that it's wasting away their lean body mass, and they lose mobility, and as soon as that happens, they lose function and quickly go downhill and succumb to the tumor burden. So if we could preserve, muscle and function, we can extend life. and maybe even, ultimately we want to reverse disease process. So we want to use, we call that like an anti-catabolic strategy. If we can preserve and even build muscle, and actually with a therapeutic intervention and combine that with the anti-cancer strategies that we're developing from my other students' projects, we can, make inroads to providing another therapeutic opportunity for people with cancer. Right now, we're just working on getting these, nutritional approaches in as an adjuvant to the standard of care. But in many cases, like for something like a glioblastoma or advanced metastatic cancer, there is no standard of care. It's just palliative care. So you want to do whatever you can to, extend the life of these patients, and that's sort of the patient populations that we're working with.
Absolutely. And so a lot of the things that you're currently doing research on are extreme cases, whether it be people that have cancer or for potentially astronauts or scuba divers. Is the ketogenic diet something you would recommend to, let's say, your average healthy 20-something who's just looking for performance benefits?
Yeah, I think it has a lot to offer. And I think, that's why a lot of athletes are, considering that an option. And it may or may not be optimal to be in a state of nutritional ketosis all the time, but I think it's probably optimal to go in and out. And what that does is when you force your body to get into nutritional ketosis, it's kind of like an altered metabolic state. It's shifting your physiology to be fat and ketone dependent and not glucose dependent. And that can be beneficial from many different perspectives. And if once you do that, something happens in your body that you can, once you've achieved kind of fasting ketosis or nutritional ketosis, it's just easier for the body to get into that state again. And, the first time is kind of like the hardest, and then the more you do it, the easier it gets and kind of the more benefits you derive from it. So that's what I've seen, the trend, and it just kind of makes sense. We gradually upregulate the mechanisms that can ensure that, nutritional ketosis is kind of a comfortable physiological state, like the more we do it. So I talked to a number of professional athletes who, a few of them have had injuries like a brain injury, a concussion, and they were getting really bad headaches. One of them was having some seizures, so they looked clinically, it made sense to use a ketogenic diet. And once they started it, they realized that their seizures, they never got another seizure again, their headaches went away, and then on top of that, they felt like from an athletic perspective, they were doing better. And even from a everyday kind of lifestyle perspective, like their mood and their attitude was better. And this ranges from hockey players to NFL guys to soccer players or football players, and of course, a number of military personnel too have adopted this strategy and done remarkably well with it.
And I guess the same kind of question about fasting. I know that after 40, like one of the leading causes of death is cancer. But for me and my friends in our 20s, fasting is something that we've talked about a lot, and it's interesting to us, but we just wonder, is this right for us? What are your thoughts on that?
Yeah, I never did it through my 20s, but I kind of would like to go back. If I could redo that, I would give it a try. When I was in my 20s, I was worried about eating as much as possible to keep gaining, muscle. And I was eating copious amounts of protein all the time, and I remember always kind of being on the edge of just feeling almost sick. I was eating so much to try to gain size and strength, but I realized in hindsight I didn't need to do that really, and it may have been counterproductive in some ways. But I can tell you that now I maintain pretty similar, or I could definitely get back to that level of size and strength, like if I wanted to, but instead of being, I'm definitely lighter, but choose to be. So you don't need to eat kind of all the time, like every 3 hours, 2 or 3 hours. Although when you're younger in your 20s, you do have a faster metabolism, but I would recommend experimenting with something like intermittent fasting. One of the benefits is that looking back, I had a pretty busy schedule in those college, and I worked on top of that. And it is very liberating. Once your body is adapted to eating low carb or low carb, high fat, and your brain's adapted to using ketones for energy, you don't get hungry and you're more satiated. So when you eat a meal, it's kind of sustaining you over time. And if you're adapted to eating carbohydrates every 2 or 3 hours, once you get hungry, your blood glucose drops, and then you start wasting muscle. Your body senses hypoglycemia and starts chewing up muscle to make the glucose. Whereas if you're fat and ketone adapted, your glucose doesn't really drop much, and you liberate fat from adipose tissue, and that fat gets converted to ketones. And ketones are very glucose sparing. So your brain would use ketones in place of glucose. And because ketones are glucose sparing, that prevents gluconeogenic amino acids being broken down from skeletal muscle and has an anti-catabolic effect. And if we think about it, that's really the benefits of fasting ketosis. So put it in another way, if we did not go into fasting ketosis, our species would quickly waste away and would have died. So it's a remarkable thing that we actually can convert fatty acids from adipose, because these fatty acids do not cross the blood-brain barrier. And your brain's like a big metabolic engine. It sucks up tons of energy relative to other organs. And so it's sucking up all this energy. And if we go without food for a while, we'll go hypoglycemic, insulin drops, and we start liberating these fatty acids from adipose, and they don't readily cross the blood-brain barrier. The long-chain fatty acids don't, but through beta oxidation in the liver, they are converted to beta-hydroxybutyrate and acetoacetate, and these are water-soluble fat molecules that readily cross the blood-brain barrier via the monocarboxylic acid transporter, and they can sustain and preserve brain energy metabolism even in the face of hypoglycemia. So the practical benefit is that we can go without food and feel cognitively well and even optimize in some way. Like, a lot of people are just more lucid when they're in it. When I have a big writing project, I will, do it towards the latter phase of an intermittent fasting, protocol, and that's when I'm most productive. And I think, you talk to a number of writers, or a number of writers have reached out to me and actually told me that, and it's like, wow, yeah, I kind of feel that too. So it's very liberating not to be fixated on food. In the past, when you're carbohydrate or sugar and carbohydrate dependent, you're kind of more or less preoccupied with food. Like, what am I going to eat next? When you get hungry, your mind tends to gravitate towards being preoccupied with the next meal. Whereas when you're in a state of fasting ketosis, and it doesn't have to be like starvation ketosis. We're not really starving until we've gone without food for a very long period of time. But we're in a state of mild fasting ketosis, or on the ketogenic diet, when we're deriving benefits from ketones independent of fasting. We have steady fuel flow to the brain, and and that metabolic state has some practical advantages because you don't get hungry and you have kind of more energy. And we know that ketones are not only a superior metabolite for generating ATP, they have unique signaling properties. So they actually function as histone deacetylase inhibitors, or HDAC inhibitors, that can suppress oxidative stress, turn on longevity genes associated with extension of life and suppression of inflammation. So it targets a specific pathway called the NLRP3 inflammasome. That was published in Nature Medicine, and the particular study used a ketone ester that we developed in the lab. The study was done at Yale, but it used a particular exogenous ketone that we developed. So you have, for decades, we understood ketones as an energy metabolite that would start to rise in type 1 diabetics who didn't have their glucose controlled correctly. And that happens only in type 1 diabetics. We call it diabetic ketoacidosis. And it's quickly corrected with a little bit of insulin. And but for the majority of population, nutritional ketosis is vastly different than diabetic ketoacidosis, where you have your glucose elevated on top of super high ketone levels. Nutritional ketosis is a very fine-tuned, or fasting ketosis is a fine-tuned metabolic state where your body is kind of optimized in many ways to use fat and ketones as an energy source, and makes you very resilient in many ways. And that's actually why the military is quite interested in this metabolic state, because it provides some benefits for resilience in extreme environments.
If someone listening to this, for whatever reason, they don't have the discipline or whatever that is to follow a pure ketogenic diet, let's say they still eat pretty healthy, we'll just call it like a paleo, where they are eating some sweet potatoes, would exogenous ketones still have some of the same benefits, or is it kind of a waste?
Yeah, that's a good question, and I get that a lot. So we actually studied ketone esters, or ketone supplementation, in the context of we first did studies in animals eating a normal, standard, high-carbohydrate rodent chow, and they would have free access to food. And standard rodent chow is like about 60% carbohydrates to 70%, and we would simply give them an intragastric gavage. We would orally feed them essentially a ketone ester, and then we would expose them to an extreme environment to simulate an extreme dive that a Navy SEAL would do on like 100% oxygen, like 132 feet of seawater, which is 5 atmospheres of oxygen. And that typically triggers a seizure within about 10 minutes in humans and in rodents. And when I first did this study, the original plan was to feed the ketone esters for about a week or two to make them acclimate to it. So they would, so the transporters would be upregulated and everything. I went into that with that line of thinking, but they were very expensive to produce, so I only had sort of enough ketone esters and enough funding at the time to do a single dose and then a single dive into that extreme environment. And what we observed is that we saw greater than a 500, almost a 600% increase in latency to seizure, which means that they could resist it has a neuroprotective effect, and they can resist seizures much greater length of time. And that was remarkable to me, because there was early work done that, with extreme fasting, you could achieve that. But I never thought that you could give, an exogenous, ketone, and then a half hour later do the dive and get that kind of neuroprotection. No anticonvulsant compounds actually that were tested experimentally or FDA approved could afford that kind of protection. So those early experiments were really encouraging, and I quickly realized that this was actually giving the brain a source of energy that preserved brain energy metabolism in the face of an extreme oxidative challenge, and that had broad implications to a number of pathologies, including brain injury and other seizure disorders, and even Alzheimer's disease, where it could be thought of as type 3 diabetes. From PET scans, we know there you see impaired glucose utilization in the brain, and Stephen Cunnane, a scientist in Canada, has shown that over time there's impaired glucose utilization in the brain as we age, but due to things like impaired glucose transporters, PDH complex deficiencies, and things like that. But that doesn't happen with ketones. So as we age, our ketone utilization capacity never decreases, whereas our glucose utilization capacity does decrease. So, with your crowd in their 20s, they might not have to worry about that, but it may actually be a good prophylactic measure if you are, for example, ApoE4 positive. You have kind of a genetic a genotype that would make you susceptible to Alzheimer's disease. And if you were to do like a 23andMe and show that, it would probably be real important for you to do intermittent fasting, ketogenic diet, at least occasionally, to get the benefits of that. And Dale Bredesen has done, some work on metabolic interventions for ketones, and talking with him, I think, he would agree. I think most of the experts would agree that you could intervene early with some of these approaches, like intermittent fasting. Mark Mattson from the NIH has done some really elegant work on the neurological benefits of intermittent fasting and things like brain-derived neurotrophic factor. So it enhances sort of like the brain's neurotrophic environment to improve brain health. Exercise does, he's shown that, but also intermittent fasting. So these are things that your audience can implement early on and are non-drug related things that they could do to enhance brain health and maybe stall early onset of age-related chronic diseases.
If someone listening, or for myself, wanted to try fasting, and I've never tried fasting, I'm guessing most of my audience has never tried fasting, how would you recommend getting started for your first time?
I would recommend not eating.
That's it. Okay.
Yeah, it's kind of simple. So the best way to approach it would be to ensure that you're well hydrated, that you don't have any underlying pathologies that would predispose you to things like cardiac irregularities, like atrial fibrillation or any kind of cardiac issues, I would say, because the things that are kind of influenced acutely or within the first 24 or 48 hours could be your electrolytes. So you want to make sure you get, adequate sodium, potassium, magnesium too, actually, and sufficient amount of fluids. Because during the fasting, the first 24 hours, your insulin will start to drop, and as insulin levels drop, that insulin causes sodium retention. So low insulin will cause you to sort of dump some sodium and have a diuretic effect, and also you're burning up some of the glycogen, which stores water. And you may feel a little bit tired and sluggish the first day or two, and that could be due to low blood glucose, but is also, I think, more likely due, or a contributing factor would be lower blood pressure, and that could be good for some people with high blood pressure. You can reverse that with just fluids and kind of electrolytes, non-caloric substances. But the diuretic effect that fasting has lowers blood volume. So we call that hypovolemia, and that can maybe limit some of the blood flow to your brain a little bit. So you just feel like a little bit woozy at times. If you're sitting in a chair, laying down, and you quickly get up, you could experience something called orthostatic hypotension. But staying well hydrated and getting mineral supplementation can prevent that from happening. I would say the first 24 to 48 hours is going to be the most difficult, and if you really want to extend it out to like 3 days, once you get past the 3-day mark, it starts to get a little bit easier. But then we're talking into more, kind of more serious fasting. Like short-term fasting would be 2 to 3 days, and then sort of shorter long-term fasting would be like up to a week, which I've done up to a week, and surprisingly it wasn't really that hard. But intermittent fasting may be the best approach for your listeners, which I do maybe about twice a week. I generally eat just 2 meals a day, but I will go maybe 2 days per week, depending on my schedule, where I don't eat breakfast, and I eat when I get home at night, starting at about 7 o'clock, and then my main meal, and then we'll kind of nibble and maybe get some snacks at night and go to bed at like 11 or 12. So I eat within maybe a 5-hour window. And can get benefits from that, because you are, by the end of that intermittent fasting day, your ketones are getting up, especially if the foods that you eat during the eating phase are low-carb ketogenic. And then that actually makes intermittent fasting easier. If you're eating a bunch of carbs during your eating process, then it may make the fasting part a little bit harder, but if you eat low-carb ketogenic during that window of eating, then it actually makes the fasting period easier.
Do you ever have like weeks or a week-long or more periods where you go out of ketosis completely? And if so, why?
Yeah, good question. I generally kind of stay in ketosis because it's kind of my field of research, and I've learned over time that my energy, my immune system, and my productivity at work is optimal if I maintain that state. I was on vacation recently, and my wife and I, we rented an RV and drove up north to see my parents. And when I was staying at my parents' house, I kind of got off my typical ketogenic diet, was eating a lot more protein, had a dessert here and there. Was definitely out of ketosis, and also around my family, nieces and nephews, and there was like a little bug going around, like a cold, like a head cold, and I had not gotten a cold in years, and I was saying, wow, maybe the ketogenic diet has been joked about as being a panacea and curing everything. And I was always kind of the impression, well, maybe that's why. I used to get one or two colds every year, and I hadn't gotten a cold in like 5 years or something. And then I got off the ketogenic diet for my stay, and coming back, I started to get like a scratchy throat. And I was like, no, I think I'm getting a I think I'm getting a cold. And I quickly transitioned back to ketogenic diet, but I think it was a little too late, because I did end up getting a cold, and now I'm back on the ketogenic diet, but unfortunately my wife picked it up too, and she's actually on the other side of the planet. She's a research biologist diving right now. She's underwater breathing oxygen actually, but needs to take some decongestants to do her dives. But yeah, I actually stayed in nutritional ketosis for many years, and have stayed, and would only occasionally break it, for just like a day or two here and there, but largely just stayed on it because I just found I felt better. My energy levels were higher cognitively. I think clear, and I like being able to come into work and put in a full day and not have to be kind of a slave to my appetite. So my appetite is kind of under control. When you're eating carbs and sugar, your appetite kind of controls you. Whereas if you're eating low carb, it doesn't have to be ketogenic, but if you're kind of generally eating low carb, and you experience it more when you're eating ketogenic, your appetite is fully controlled. Like if you see chocolate cake or cookies or something, it looks good to you, and you could eat it, and it may be pleasurable, but you have control not to eat it. And that's some of the practical benefits. And also, too, you just have more energy. At least I do. And not, I'm describing my experience. I don't think all the people out there will experience that, and some people have a rough time getting off of their sugar addiction, because our brains are really adapted under normal conditions. About in a fed state, under normal conditions, about 100% of brain energy metabolism is derived from glucose. Once we fasted for 1 week, George Cahill from Harvard Medical School shown in his fasting subjects that after about a week to 10 days, about 65 to upwards of 70% of the brain energy metabolism is derived from beta-hydroxybutyrate and acetoacetate, the two ketone bodies that are predominantly elevated in a fasting state. And that provides a really important metabolic advantage, we think, but also makes you resilient against hypoglycemia. So when your glucose drops, you don't have this overwhelming craving to go eat food. So and actually the subjects that he fasted and did a lot of elegant metabolic physiology on, he injected one group of subjects with insulin, 20 IUs of insulin, and dropped their blood glucose down to like 1 to 2 millimolar, which is like on a standard blood glucose meter, it's about 18 to 20 milligrams per deciliter, which would more or less be universally fatal for everybody. But his subjects were in a state of fasting ketosis, so their brains had adapted to using ketones as an energy source. And even though they were severely hypoglycemic, they were asymptomatic for hypoglycemia. And it even did like cognitive tests. They were very lucid and clear because their brains had adapted. Their brains had that remarkable metabolic flexibility to adapt from using glucose to using ketones. And that is real. So that was 1967 that was published. So they literally had to change some of the medical textbooks to describe alternative energy substrates that the brain can use. Now we know it can use lactate, a few amino acids like glutamine, and but primarily ketones like beta-hydroxybutyrate when you're in a fasted state. So that there's incredible utility to that. It's a hardwired, evolutionarily conserved mechanism, state that the body goes into. And I think that state is largely silenced by the advent of agriculture and processed carbohydrates and eating 3 times a day. It was a normal state of man for him to enter ketosis occasionally. It's abnormal for him not to enter ketosis. So I think getting into ketosis every once in a while is really a good thing. And I think Mark Mattson of National Institutes of Health has actually studied that a lot. I actually did a podcast with him on IHMC STEM Talk, which is another series of podcasts where we talk about these subjects. And he's a big proponent of intermittent fasting and described various protocols that you could do. I really do like the kind of 18 hours fasting and then 6 hours of eating, or window of eating. It has worked really well with me and with a lot of people that have been in contact with me.
Yeah, I'll definitely have to try that out.
Okay.
One other question, going back to exogenous ketones, if we were to want to experiment with those, under what circumstances and what time of the day is it best? Is it a morning thing, or is it something you should do before exercise, or how do you usually take them?
So on a day that I'm quote-unquote fasting, I generally eat like a small ketogenic meal in the morning. But if I'm fasting, I will usually put a little bit of MCT oil in my coffee or butter in my coffee, so that can sort of jumpstart your own ketone production by giving ketogenic fats. And I'll kind of ride that caffeine ketone high throughout the day, usually kind of busy until like anywhere in the afternoon. I will mix up an exogenous ketone product. And I have a couple, that I keep in my office. KetoCana from Keto Sports, Pruvit makes a Pruvit Keto OS, and then I'll mix up one of these products and I will drink it around anywhere between noon and 2, and then I'll kind of really be on fire and really focus on whether I have teaching obligations or research or just working at my office. I'll work again all the way to like 6 or 7. And before I head home, and either sometimes I stop at the gym, sometimes I don't, but I usually get home and have a meal, and then I do some activities. I take my dogs like for a walk or do some kind of activity, and then usually snack again, lightly snack at nighttime before I go to bed. So that's my typical, and usually ketogenic foods and ketogenic snacks too that have used. Quest Nutrition has a range of ketogenic food products. They have prepackaged ketogenic meals if you go to Quest Keto. So a lot of people are like, they just don't have time to, make the ketogenic diets, but there's foods already made for you that you can order if you like. And they also have snacks like ketogenic chocolate bars or Reese's bars or things like that are formulated in a way that if you consume them, you can stay on a ketogenic diet.
I want to be respectful of your time, but I have one last question I always ask my
Sure.
guests, and this is a more general question, and that is if you could go back in time and tell your 20-something-year-old self, give him whatever advice, or more specifically, give advice to all the 20-somethings listening right now, what kind of advice would you give?
So for me, I've made a lot of mistakes through my early years through the 20s, so I wouldn't go back and change anything, because I think most of what I have to be thankful for, kind of I learned through my mistakes. So maybe that brings me to what my recommendation is: don't fear making mistakes. Be bold. Be kind of, don't be afraid to take risks, because even if you do fail, that failure is only feedback, and it's all about picking yourself up and moving forward. And I mean, you may have to go into various, you may have to change your major topic that you're focused in college from, social sciences to engineering or vice versa, and really have to experiment with a lot of different things in life to figure out where your niche is. And I think it's really important that your listeners actually do the experimentation, self-experimentation, and get the experience in the real world to find out where their niche is. Because once they're really passionate about something, it may be something that they would think they could never be successful, at making money off of or having a career off of. Like, I never thought I could build an entire research program and get tenure at a university off synthetic ketones. At the time, synthetic ketones were thought of as a metabolic poison. But I knew in my heart that they had therapeutic potential, and I knew that if I could just get the money to do the research, I could kind of show everybody. So, and I made a lot of failures in research along the way, but I think that's important. So don't fear failure. Just go full steam ahead and pick yourself up. You're going to fail no matter what. I think the people who have been most successful are the ones that have failed the most. So that, I guess that would be my recommendation.
I love it, and I totally agree. Dom, where can people find out more about you and all the research you're doing?
I have a website called ketonutrition.org, all one word, ketonutrition.org. And on that website, I just compiled a bunch of links on there. That would include links to an academia website, which has like all my all our research publications, and some of them are actually publications that you would otherwise have to pay for, that you could download books and publications for free from that website. And then I have, on the ketonutrition.org website, I have a list of ketogenic diet consultants that can help people that have, seizures or even cancer, or people that just want to enhance their exercise performance. So there's exercise consultants on there that specialize in the ketogenic diet, and there's clinical trials, there's other stuff on their podcast. So I would direct people there, ketonutrition.org. I have my faculty website too, but I generally like to put everything in one spot, and I think that would be the best place to direct them.
Awesome. Dom, thank you so much for coming on the show. I really appreciate it.
Thanks for having me, Travis. I appreciate it.
Hey guys, I hope you enjoyed that video, and if you did, make sure you hit the big red subscribe button down below. You can also check me out on Facebook and on Twitter, and I release a new video every Monday, and by hitting that subscribe button, you'll get those new videos every Monday. And this is really a podcast. It's also a website. You can check out the website. It's howtodoyour20s.com. I'll put a link right over here as well. And what it's all about is trying to improve your life. And we specifically focus on things that people in their 20s are interested in. So make sure you like the video if you liked it. Subscribe. Like us on Facebook and Twitter, whatever. But I hope you enjoyed the video, and I hope to see you again on another video.